Good morning, my dear students. How are you? I hope you all are fine. In the last video, we started our new topic in the first chapter, refraction. Okay, in that section, we discussed what is refraction and refraction through a glass slab. Today, we are going to discuss a new session, that is laws of refraction. Okay, laws of refraction. There are two laws of refraction. For explaining that, we are consider two medium. One is air and second one is water. Okay, here a light is coming from air to water. That time the direction will change, or this ray is deviated here. Okay, that is refraction is take place. Here this is our normal, and angle between this incident ray and normal is incident angle, and the angle between this normal and this refracted ray is angle of refraction. Okay, this is the interface dividing these two medias. Okay, according to laws of refraction, the incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Okay, this is the first law of refraction. Is it clear? What is that? The incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. This is law of refraction, first law of refraction. And the second law states that the ratio of, the second law states that the ratio of sine value of angle of incidence to the sine value of angle of refraction is a constant. I repeat, what is second law? The ratio of the sine value of angle of incidence to the sine value of angle of refraction is a constant. That means sine I by sine R equal to a constant. What is the second law? Law of refraction. The second law of refraction is the ratio of sine value of angle of incidence to the sine value of angle of refraction is a constant. Okay, this is the second law of refraction. This law is also called Snell's law. Snell's law. Okay, Snell's law. Here, this constant is called refractive index. Refractive index of second media with respect to first media. Listen, one more. What is Snell's law or law of refraction, the second law of refraction, it is the ratio of sine value of angle of incidence to the sine value of angle of refraction is a constant. This is Snell's law. Okay, this constant is called refractive index of second media with respect to first medium. With respect to first medium. Okay, this constant is represented as n, that is sin I by sin r equal to n. Okay, this is Snell's law or second law of refraction. Clear? Okay. Laws of refraction, that is two laws of refraction. The first law states that the incident ray, refractor ray and the normal all lies in the same plane, and the second law, that is Snell's law, states that the ratio of sine value of angle of incidence to the sine value of angle of refraction is a constant. That constant is represented as n, that is sin I by sin r equal to n. This n is called refractive index of second media with respect to first media or refractive index. Clear? This is laws of refraction. Laws of refraction. Is it clear? Okay. Next, we are going to discuss this section, refractive index. Refractive index. The refractive index means the extent of the change in direction of the ray of light in a given pair of medium is called refractive index. What is the refractive index? The extent of the change in direction of the ray of light in a given pair of medium. It is called refractive index. Let us consider two medium. Here this is our incident ray, and consider two medium 1 and media 2. Media 2. The light ray is coming from media 1 to 2. Okay. Here the speed of light in first media is considered as v1, and the speed of light in the second media is considered as v2. Okay, that is, if the speed of light in the first medium is v1 and in the second medium is taken as v2. Okay, then the refractive index. What is the symbol of refractive index here? N. Okay, the refractive index of second media with respect to first media is equal to the speed of light in media 1 divided by speed of light in media 2. That is, the refractive index of second media with respect to first media is equal to the ratio of speed of light in media 1 to the speed of light in medium 2. Okay, that means here what is the speed of light in media 1? V1 divided by, what is the speed of light in media 2? V2. That is the speed of light, the refractive index of second media with respect to first media. That is the refractive index of second media with respect to first media is equal to the ratio of speed of light in first media to the speed of light in second media. Clear? And similarly, what is refractive index of first media with respect to second media? Here, this is refractive index of second media with respect to first media. Clear? Then, what is refractive index of first media with respect to second media? It is the ratio of speed of light in media 2 divided by speed of light in media first. That is V2 by V1. That is N12, refractive index of first media with respect to second media is V2 by V1. Is V2 by V1. Clear? Okay. In the first section, in refractive index, we get N equal to sin I by sin R. And the second section we get N21 equal to V1 by V2 and N12 equal to V2 by V1. Okay, next we are going to discuss absolute refractive index. Here the absolute refractive index means the refractive index of a media with respect to vacuum or air. I repeat, the absolute refractive index means the refractive index of a media with respect to vacuum is called absolute refractive index. That means here the first media is taken as air and the second medium we take water, glass, anything. Okay, that is here the absolute refractive index Nm equal to speed of light in air divided by speed of light in any media. Okay, we have the speed of light in air is represented as C and the speed of light in any media is V. Therefore, the absolute refractive index Nm equal to C by V. Okay, I repeat, here the speed of light in air is considered as C. The value of C is 3 into 10 raised to 8 meter per second and the speed of light in media is taken as V. Therefore, the refractive index, absolute refractive index or refractive index of medium is equal to C by V. This is the equation for absolute refractive index or refractive index of any media. Okay. Next, very important point, that is the refractive index of a media is directly proportional to the optical density. Listen, that is the optical density is directly proportional to the refractive index. What is the meaning that if the refractive index is less, the optical density also less. What is the meaning of that term? If the refractive index of less, the optical density is less, means the medium is rare medium. If the refractive index is high, the optical density also high. That means the medium is considered as denser medium. For example, in the case of air, the refractive index is 1. And in the case of glass, the refractive index is 1.5. Which one has greater refractive index? Glass. Then which one has greater optical density? Is also in glass. That means the glass is denser medium because it is optically high. Optical density is high and the refractive index is high. In the case of air, the refractive index is less compared to glass. That means the optical density is less. That is, the air is rare medium. Clear? That means the optical density is directly proportional to the refractive index. This is refractive index. Next we are going to discuss the problem sessions based on these topics. Okay, first question. Calculate the refractive index of glass with respect to air. In bracket, the speed of light in glass equal to 2 into 10 raised to 8 meter per second. Okay, how to calculate the refractive index of glass? First, you write the given values. What is the given value? The speed of light in glass, that is V equal to 2 into 10 raised to 8 meter per second. How to calculate the refractive index of glass with respect to air? We are using the equation Nm equal to C by V. From that equation, another term C is a constant. C equal to 3 into 10 raised to 8 meter per second. Therefore, the refractive index of glass equal to C by V. What is C? 3 into 10 raised to 8 divided by what is V? 2 into 10 raised to 8. Here 10 raised to 8 and 10 raised to 8 are cancelled. What is 3 by 2? 1.5. That is, the refractive index of glass is 1.5. Clear? Okay. The next question. The light enters from air to glass having refractive index 1.5. What is the speed of light in the glass? Okay, I repeat. Light enters from air to glass having refractive index 1.5. What is the speed of light in the glass? The given value is speed of light in vacuum is 3 into 10 raised to 8. In this question, the given values are Ng equal to, that is the refractive index of glass is given in this question, that is Ng equal to 1.5, and the speed of light in vacuum or air C equal to 3 into 10 raised to 8 meter per second. What is the question? What is the speed of light in glass? Okay, that means here we want to calculate Vg. What is the relation between these three terms? We have Ng equal to C by Vg. Vg means speed of light in glass. V also returns. Okay, Ng equal to C by V. From this, what is Vg? Vg equal to C by Ng. Substituting the given values, 3 into 10 raised to 8 meter per second divided by 1.5. What is 3 by 1.5? 2 into, what is this? 10 raised to 8 meter per second. This is the speed of light in glass. Okay, that's all. I hope you all are understand this two problems and what is refractive index, absolute refractive index. Understand? Okay, thank you.